Question 11 asks if 181.1 grams of AlNO3 reacts with 102.1 grams of CaO in a double replacement reaction, how many grams of each product will be produced? First, you write the balanced equation. Then, to find the limiting reactant, you do 181.1 grams divided by the molecular mass, which leads to 0.850 moles of AlNO3. Then you do the same thing for the CaO, and you divide the 102.1 grams given to you at the beginning by 56.1 grams, which is the molecular mass, and that gives you 1.82 moles. And then there is a 2 to 3 ratio of moles of AlNO3 to the moles of CaO. To find out which is the limiting reactant, you multiply the 0.850 moles of AlNO3 times 3 over 2, which leads you to 1.275 moles of CaO. Then you also multiply the 1.82 moles of CaO by 2/3, which gives you 1.21 moles of AlNO3. The limiting reactant is the AlNO3 because 0.850 moles of AlNO3 present is less than the 1.2 moles of AlNO3 needed. Then you calculate the moles of each product produced using the moles of the limiting reactant. Since there is a 2 to 3 ratio of the moles of aluminum nitrate to the moles of calcium nitrate, and there's also a 2 to 1 ratio of the moles of aluminum nitrate to the moles of Al2O3. To find the moles of CaNO3, you multiply the 0.850 moles of aluminum nitrate by 3/2. That gives you 1.28 moles. To find the moles of Al2O3, you multiply 0.850 moles of AlNO3 by 1/2. That gives you 0.425 moles. Now you convert each product to grams of each product. So to find grams of CaNO3, you multiply 1.28 moles by 164.1 grams per mole, which is the molecular mass. That gives you 210. Then you multiply the 4.25 moles of Al2O3 by 102, which is its molecular mass, and that gives you 43.4. Now on to skills practice. This is question 1. You are given the following combustion reaction, and you have to consider it to answer the questions and use the information given to you. You are also told that 125 grams of C4H10 reacts with 415 grams of O2. To find out which substance is a limiting reactant, you look at the mole-to-mole ratio between C4H10 and oxygen. You divide the 125 grams by the molecular mass, which is 58.12, and that gives you 2.5 moles of C4H10. You do the same thing with oxygen, which is 415 grams divided by 32, and that gives you 13 moles of oxygen. Now you multiply the 2.5 moles of C4H10 by 13.5, and that leads you to 14.0 moles of oxygen. The 13.0 moles of oxygen are multiplied by 2 over 13, and that gives you 2 moles of C4H10. The limiting reactant is O2 because 13 moles of O2 present is less than the 14.0 moles of oxygen needed for the reaction to occur. Part B asks what mass of carbon dioxide and water are produced. You're going to use the limiting reactant, and you're going to use a mole-to-mole ratio. That's 13 to 8 ratio of moles of oxygen to moles of carbon dioxide. And there's a 13 to 10 ratio of moles of oxygen to moles of water. To find the moles of carbon dioxide, you multiply the 13 moles of oxygen by 8/13, and that gives you 8 moles. The moles of water becomes 13 moles of oxygen times 10 over 13, and that's 10 moles. Now you multiply the 8 moles of carbon dioxide by its molecular mass of 44.01 grams per mole, and that gives you 352.08 grams of carbon dioxide produced. For the grams of hydrogen, or for the grams of water produced, it's 10.0 moles times 18.0 grams per mole, and that gives you 180 grams.